what I want to do is I want to replace the LEDs with one LED, but this is an RGB LED. Okay, so here's the RGB LED, and the longest lead on it is ground. So I'll just connect ground. I've just put my power supply on 2.2 volts, and let's give this a go. So there's red at 40 milliamps. That's way too much. Hang on, I've probably burnt that out now. 20 milliamps, that's better. So 2.1 volts red. Okay, and the next one is green. Oh, it's not enough voltage now. Hang on. Oh, that needs quite a lot more. 3.3 volts, and that's green. And finally there's blue. And there's blue. So yeah, what I'm thinking is that I'm going to take those two out and replace it with this, and I'll light the red one when I need to, and the green one when I need to. So red can be draining and green can be done. Seems to make sense, doesn't it? So there is something a little bit complicated about this, but I'm not going to go into it too much. But that is, over here on this design, I've got them both passing through one resistor, but that can't really happen with this because the red the red LED needs to have a different resistor than the green LED, and that's just because of the makeup of, well, the way LEDs work. So I'm going to be putting two different resistors in, and I'll tell you those values in a minute. I'm just going to go and find out what they are, and we'll get started. So I've got my resistors. I've got the 150 and I've got the 68, and those ones will do for this project. So what do I do here? So first of all, I'll take the ground resistor out. Oh, that means that I could have left the buzzer where it was, but not to worry. I'll take the ground resistor out. Okay, now. Okay, I think the easiest thing for me to do is to just push this in here like this. We've got somewhere solid to work with it now. It just means there's going to be more mess with wires, but you know, these things happen. So we'll go from ground to ground to start with. I might as well use this ground over here. Then right, I can't actually remember which resistors are what again now, so let's take these LEDs out. So there were pin 3 and pin 5. So pin 5 is draining, if I remember rightly. So pin 5 is draining. In fact, I'll probably just put them in and work it out later. So let's get one of these pins. So insert cell now and press when ready. So okay, it's draining. So let's see what pin 5 does. That's green and that's red. So that's the red one. Okay, and red needs the 150 ohm resistor. So I'll get the 150 ohm resistor and just push that across if it will go. I'm not sure if that's going to reach. Push this in here. Okay, so I've pushed that in there like that and connected up. This is getting very complicated now. Let's try again. Okay, draining, and now the 68 ohm. So let's push this in here. I've got the 68 ohm one in, and now I need another wire. Let's press drain again, and we'll go from the, oh, it's not there actually, here to pin 3, and there we go. So press to start. So it's red to show it's draining, it should go green, and green to show it's done. So that's good, and it goes off. I suppose we could have blue as well actually. Blue could mean nothing maybe. Blue could mean that it's on but nothing's happening. I suppose that makes sense, doesn't it? So blue, I don't know which resistor blue would need. I think it would probably be, I think it would probably be another 68. So I've wired the blue one up to pin 12, but pin 12 is an SPI pin. I'm not 100% sure if this is going to work, but we'll see. Also, remember that pin 2 needs to be connected to ground. So before I had it sort of in the ground rail and the ground rail connected to ground, but remember that's not the case anymore. So you need to put the resistor from pin 2 to ground. Anyway, let's go and deal with this pin 12 business and see if we can get it working. Okay, so let's define another pin. So draining, let's say, I don't know, but a totally rubbish name, but let's say the nothing pin. Pin 12. Now I've never actually done this, used SPI and one of the unused SPI pins at the same time, so I don't know if this is going to work, but we'll soon see. So nothing pin. Nothing LED pin. Is that what I've called it over here? Nothing LED pin, okay. So we should have a function to change the pin. So we'll probably need to do something with this, but to start with I just want to test it. So say void nothing pin on, bool on. Well, let's just see if this works or not. So nothing LED pin on. Let's call it over here and just see if it works. It's gonna have to be over here, of course. So turn nothing pin on, true. That turn load on, false. We shouldn't really need that, but I suppose just for the sake of completeness we can add it anyway. So now I've got to get my UART and flash the Pro Mini and then put it back. So I'll do that now. To my surprise, it actually worked. I've just gone and give it a quick test and it worked. So let's carry on tidying up. So nothing pin on, turn load on. I suppose that should be load pin on really. But then again, it does actually turn the transistor on as well, so whatever. So nothing pin on. This needs to be called, I don't know, completed pin on really. So completed pin on, and that should be that. So completed pin on. I can't remember what it was. Completed. So completed. We need to change to completed pin on. So let's have a quick look. Well, that needs to say on to start with, actually. So completed pin on. Let's replace that one. Find the next. Replace. Find the next. And we're back to completed pin on. So is that all? Looks like it is. Okay, so you know, a bit of tidying up there. So let's go back over here. I suppose for completeness again we should have the the completed pin. Completed pin needs to be off at the startup. Okay. Now when we do something to one of the LEDs, we need to do something to the others. So so when these three are called, something else needs to happen. So let's have a look. So nothing pin on and the other two are off. I suppose this is quite straightforward now really. Okay, since we've done it with these two, I think it would make sense if I finished it off. So we've got a nothing pin, completed pin, and the load pin. Really it should be load LED pin or something, but whatever. So draining LED pin it's also called. Maybe I should call it that actually. Yeah, draining LED. Draining LED pin on. Draining LED pin. Right, okay. So I'll put this over here. tidy this up a bit more. And then this draining LED pin needs to go over here. And we'll call it over there, be a bit tidier. So that's that done. Now we want to do something a bit more special here. If we turn one of these on, we need to turn the other ones off. This is a really lazy way of doing it, but it should work. So if the nothing pin is on, then turn the other one off. So yeah, it's a bit lazy because it might be that when the nothing pin is on, the other ones can't possibly be on because of the way the code's set up. But like I said, this is a very lazy way of doing it, but it'll work. So let's copy and paste these down here. So if the nothing pin is on, turn the other ones off. So we need to change this here. And if the completed pin is on, turn the nothing pin off and the draining pin. Alright. There's another thing we need to do as well. Where it says display menu 1, it says completed pin on off. Basically it says turn the completed pin off. We don't really need to do that anymore. What we're going to do instead, well, let's just delete that to start with. What we're going to do instead is we're going to call this in menu 5 where it says user input. So display menu 1. So we need to do this here. So if somebody's on the summary and they click or they press the button, then we want to put the nothing pin on, and that will of course turn the other ones off. So let's do that. Right, so I've turned this thing on. It says insert cell now, press run ready. You can see it's still blue light, and now I press go and it's gone to red. Finish, it goes to green, then back to blue. So we're done. But now I've changed the Nano to the Pro Mini. We've got two potential problems. One is that we might have loose wires again, and the second problem is that the voltage reference might be different. So I don't want to spend too much on this, but let's give this a go anyway. So let's check out the voltage reference to start with. We need this to be 4.65 really. 4.65. If it's not 4.65, then we've potentially got a problem. Yeah, it's not 4.65, so we're going to have a bit of a problem there with accuracy. Now I don't know if this depends on the power supply or what, I don't know. So 4.55 it's saying. So I thought I'd just quickly show you an overview of this thing up to now, and we'll just go over what we've got. So we've got the tact switch, which is for getting user input. We've got the IRLZ44N, which is the switcher to switch the drain on or off. We've got the base pin, sorry, not base pin, the gate pin resistor, and that's just to limit the current from the Arduino to this thing here, to the MOSFET. Then over here, also on the same wire, if you like, is a pull down resistor, and it pulls it down to ground. And the reason it does that is because we don't want the thing floating. We either want it on or we want it off. Because if this thing's floating, it can cause the MOSFET to turn slightly on, and it will get very hot and whatever. We don't want that to happen. Then we've also got the buzzer, which has just been added today. We've got the OLED. We've got the LED, which is added today with the 3 resistors. If I remember rightly, it's got 2 68 ohm resistors for green and blue, and it's got a 150 ohm resistor for the red one. Then we've got the resistors over here, which I can't remember what they are. So they're brown, brown, white, white, and they appear to be just limiting the current which can be drawn into the Arduino, and the reason for that is because if you didn't have these resistors, potentially this lithium-ion cell could power the Arduino, and we don't want that because we don't want the drain on the cell, and also we don't want power to be going into the Arduino because that's not what we're trying to do. And yeah, I've also added this today, this power thing, so that I can power it with a phone charger. So there we go. As far as I'm concerned, it's more or less finished.